All right, day 31. Really quick day because I need to do homework, but I don't have time until later night. So leetcode today. I said I was gonna do project. I don't know when I'm gonna do the damn project. The hell, I cannot type. Let's do. Wait, what was the day today? 30, so 31st. Day 31. LeetCode problem. Oh my goodness, I'm cooked. I'm not solving this. 35%. Y'all see this? I'm not solving this. Oh my goodness. I'll attempt it, but I'm probably not. Both 30%. Hold on, let's look at the discussion. Oh, the actual code difficulty is not that bad. Okay, alright, it's not that bad. Hold on. You're given 0 indexed nums and nums and k. In one operation, you would take two smallest integers x and y. Take the minimum operation to exceed thresh value 2. I don't know the first one. What was this? Take two small integers x and y. Okay. Maybe take a heap. Pop. Add xy times 2 and xy plus xy anywhere in the array. How big is nums? Nums is at least big 2. Return the minimum number of operations needed so that all the elements of the array are greater than or equal to k. Return the minimum number of operations so that all elements are greater than or equal to k. So 2 operations? Oh my goodness. So what is the topic? Okay, yeah, see, I knew it was some kind of heap. You know what? I'm doing heap. I think I can do it. If I do import, like I just from tools, right? Wait, so in the first one, we remove elements 1 and 2. I'm doing just heap, but why do we need to simulate anything? I mean, I guess, right? Oh, wait, it has to be some kind of condition, right? Return the minimum number of operations so that all the elements of the arrays are greater than. Oh. I see. If I remove 1 and 2, then add 1 times 2 plus 2 to nums, then the nums equal to 4, 11, 10, 3. In the okay, I think I got the solution. Oh wait, this is not that bad. Hold on, I think I can solve this. Basically, if we keep the way we check that if all the elements are less than or equal to k, we just keep checking if like the root is always smaller or equal, because that is the smallest value, right? I believe Python is min heap, so I keep min heap. If the min heap, but the thing is, the small maybe I can keep 2 heaps, or how do I get the largest value? Get the largest value in a heap Python. Should I keep a max heap instead? Right? 1 for. Wait, hold on. Let me do some testing real quick. Right, I'm gonna do some testing before I really solve this. So if I have n here, wait, let me just take, right, and n. So let's do heap q heap q dot heapify n, right? Right, let me print n real quick, right? I believe this will be sorted. And let me just run python 3 main.py. What? Oh, wait, python 3 solution.py. So now it's sorted. Wait, is this not sorted? Well, if I pop it off, wait, let me see something. Let's do what before and after heap, right? It's not sorted, but it's like heap sorted. Like if I pop it off, it will be sorted. I know I can do this. Wait, what? Hold on. So it's like heapified. But what would happen if I do max on this? 11. But let's say like let's do like heap. I swear there's a method, man. There's a Python heap. There's like a method to get something that's, you can add it, replace, merge, n largest. What does n largest do? It returns so I can print. Heap q n largest, and then we have to do a key. Oh, n is the thing, and then Okay, I don't know if this is what I'm looking for. I don't think this is what I want. Wait, so here's the thing. Let's think theory. Theory by heap for a min heap, the largest or the smallest value in the maybe I should do max heap. Basically, if I did a max heap, I would have a hard time getting. Take the two smallest integers x and y in. Like I can have like two heaps, but that's like very memory intensive, right? I could. What would happen if I heap if I don't want to copy the thing. That's such a bad thing. I'm not trying to copy stuff. Oh crap. Add any. Okay, what is this thing here? Add in the first we can remove 1 and 2, then add. Oh. You apply that value. Oh, all the elements are greater than k. Oh, so we want everybody in the k to be. Oh, this is not bad. Okay. Yeah, so we apply all the values in the. Like we apply all the values in the thing. It needs to be greater than k. So this is a maxi problem then. Well, yeah, no, this is a mini problem. If the smallest, just because you have the smallest value, I have to iterate. I have to check constantly. In the first operation, we remove elements 1 and 2, then add 1 times 2 plus 2 to nums. Nums becomes equals to 4, 11, 10, 3. In the second operation, remove 3 and 4, then 3 times 2 plus 4. Nums becomes equal to 10, 11. So we can stop. It can show that 2 is the minimum number of operators needed to show that all the elements of the array are equal to. So I could do a heap. I think heap is good, right? What would be a really fast way to check if I've met my condition? I'm gonna loop through it. We'll optimize later. Let's just think of a. So I think I can do this. So if we do, should we do min heap? Yeah. Right. Let's heapify heap q.heapify nums, right? So this is a min heap by default. Then we're gonna do we're gonna essentially CNT is our answer and we return CNT. CNT, right? That's our count. Then while true, I don't know the condition. I'm just gonna run that for now. Let's pop. So heap q dot pop heap. Yeah, heap pop, right? And then that's nums. We want to do this twice. And I want this here. Let's do x, y. I can guarantee if as at least 2, so I'll be safe to do this. Well, not really. I have to check. Maybe this is nums greater than equal to 2. At least 2, right? Okay, so if I pop it twice, right? At least this has to be true, right? I don't want to pop if it's too small, right? Right, then CNT like 1 or something. For every n in nums, let's do this. For every I in range of length of nums, nums I equals nums. Okay, the formula. We add this to the what do I apply? Oh my goodness, this is harder than I thought. Anywhere in the array so that it's super minimal. After 2 operations, nums become equal. We can remove 1 and 2, then add to nums. That's 4, so we're adding 4. Okay, now I'm misread the problem. Hold on, I'm very much misreading the problem. So you just add it. So this is 100% a heap problem. I'm just adding this back. And then you keep doing this. It's 6 tenths. We add 10 to the array. Okay, so we have to add this back to the array. Hold on. Yeah, add this back to the array. So, heap push nums the val. Let's call this. It's like max of or min of xy times 2 plus max of xy. Yeah. And we do val heap q. We add it back. And then we just do this thing for every n and n's. If n equals all greater than a flag, put this false. If n less than k, just stop. Right, so that's what so if then flag false, let's call this true. Let's assume that we found our answer. If we find a value that's too small, we do that and just break out of this. No need to check anything else, right? And we increment. Now, in the case that this is true, we can just return immediately CMT. Because we want to be minimal as possible. And then in the case that we do this, then we just return out there too. So I don't know. Maybe this works. Wait, it does. Of course. I got 1, 3, so we're like 1 off. I think it's returning too early here. I guess you can just return true, like while true forever. And eventually you gotta be to a point, right? No, I can't. This is too dangerous. I can pop out if out of the range, you know. I got that formula right. Right, if n less than k, maybe +1. Oh my god, this is such a scam. Oh wait, I messed up. Seems like I'm returning always out of here, so. Yeah. This would run, we pop the 2 values. Right, apply the thing. Oh, I see. I see. If we don't, look, I have to check. Maybe it's an edge. If the length of nums is 2, is equal to exactly 2, which is the minimum, then return 0. Not just yet. I have to return 1 or 0, because I can apply it once. If then if num, I guess I could do x, y, nums, right? If x k equals 1, or like k, if k equals k, like k equals k equals x, or well, I can do this, right? I can say if k greater than x, or and k, not k, I have to say k is less than equal to x, and k less than equal to y, return 0, return 1. This is the edge case. Other than that, this is assuming that it's bigger. We should apply. I just realized. How am I gonna know if, like, this could be the case where every single element is k, like k long, you know? Like, every single element could be already bigger than k that I wouldn't even know it. Ooh. If that's the case, then the minimum, right? I have an idea. I can definitely check that immediately. Ooh. If the so hold on. Essentially, I can do this. Min, max. Right? What am I doing? Mig. I don't even need any values. I can just, yeah. If the k is greater than or equal to min, or less than or equal to min of nums, opposite. If it's greater than or equal to, or greater than, or we're saying min, we should say, so being smaller, then return 0. We're not return 0. We're saying, yeah, if the smallest value in the thing if the smallest thing in the nums is greater than or equal to k, no need to do any of it. It's probably, no, that's a bad logic, because there could be, look, the smallest value could be 1. No, if the biggest value, does that make sense? If the biggest value is smaller than, if k is greater than is greater than or equal to at least the biggest number in the list, you gotta at least do it once. Right? Right, you gotta do it at least once, right? If the maximum is bigger, then you still gotta do it, right? So what does that mean? If the maximum number is, if the minimum number of the list is there, do I need to do this operation? There exists some sequence operator which all elements of, okay. This is taking longer than I can. Hold on. If k is greater than max nums, Do I need to check? This just assumes, like, I need to make sure that I don't, like, if I don't need to do this, then don't do it, right? If it's already that, right? Can I get some guarantee that the first iteration at least is minimum 1? After one operation, nums becomes equal to 2493. Okay, heap and what else? Remove the 2 elements before the operation, insert them. I already did that. So if I start the process, it's gonna be guaranteed, right? Like I can guarantee this part, but I fail at a certain part. Let me try it again, right? Run. I should not do this. I get the answer wrong. Why am I missing 1? Should I start with 1? Like, is it always guaranteed that I have to do at least one operation, right? Like, what priority queue would this be? Like, I'm using like, I know I can solve this. It's not that bad. You just keep doing this, right? This is not true. This doesn't make sense. It's not guaranteed. Like here, this is an example of. This is an example of where I don't need to perform this operation. So let's prevent that, right? If x, right? Why am I over counting? What? Or under counting? Right, if I'm under counting here, right? I pop off, I get 1, 1. It's 2 plus 1, so 3. We add 3 to the joint. 2 and 3, that's... Let's do this one. We remove elements 1 and 2. Like, this is the thing that's gonna check if we need to continue, right? For every n in nums, if n less than k, flag equals false. If flag, right? Like if all the numbers are bigger than, it has to be strictly smaller than k, then we're good. Then if it doesn't ever reach this, then maybe I gotta do CNT plus 1 because we did that's true. We did 1 before it. We just did it, and then we just got, so we do need to do that. Then I do that. Okay. That's kind of returning the same thing as +1. But this is only the case when we check, though. Because maybe, okay, actually, I'm going to say every time. I know why. This should be here. So that is a 1. We just did 1. This is that operation. That's it. Now this is the validation. This is returning the right stuff. This is the validation, and we go down here. Oh, do that. It's getting there, but now I just need a thing that checks for the. Yeah, now I need to determine how do I check if all the elements are already, like, why enter this? So I could potentially not even enter the while loop, right? Return CNT, which is a 0. So what should guard this? While, I don't know what would guard the while loop. Like, there's gotta be like a trick, essentially saying if the smallest number is greater than, like, if the biggest number is greater than k, I still gotta check it because there could be smaller numbers. If I check the smallest number in the list and it is greater than or equal to k, then yeah, is that a wrong logic? If the smallest number in the list is less than k, I mean greater than equal to k, then I can just return 0. Like, I don't need to check, right? Because if that's the smallest, yeah, that's exactly what it is. If the smallest value in the array is greater than k, I don't need to check anything else because that's the smallest one. If there were something that was smaller than it, I would have gone, that would be the one that would check. So yeah, this should work. This is 100% the solution. Well, I don't know why. This will never return. So we can do, this is the final solution. Right. Yeah, there you go. Not bad of a, like, it wasn't that bad. Like, I don't, like, yeah, this is the weird edge case. How do people solve it? Yep, this is kind of, whoa. Wow, oh yeah, that's the same thing. That's kind of my same logic. It literally checked the first element, which is the smallest. That's actually way cleaner. I should have done that. I don't need to do this stuff here. Yeah. I'm wasting the heap. So I could return CNT. That is a smarter solution. I see. Always checking for the smallest one. As soon as that is the case, then just get out of it. Why do I need to check every single one? This is kind of shitty here. Yeah, that kind of made it worse complexity. Yeah, I don't even need any of this. Way smaller. The code is way simpler than my crappy solution. Okay. Like, yeah, just always checking for the smallest element. And if that is ever bigger than k, we've found every solution. We found a list that is perfectly the case. This is a better solution. 100%. Yeah. And log n. Yeah. Easy. Very easy. Why is this so slow? This is ridiculous. This is not even that bad. Yeah, simple min heap. I was kind of overthinking it, but it is what it is. Anyways, thanks for watching. I'll see you for tomorrow's.